Right, in this video, I'd like to go over the other popular method for calculating torque. It's not to my taste personally, but I know a lot of people like it and a lot of people use it. And at a minimum, it's useful to hear because some of the terminology that's used here is popular terminology. So it's useful to know what other people are talking about. Or you might like this method better, who knows? So step one is the same. Step one is you draw a free body diagram. The two key features of that diagram are the same. You want to make sure that you have the axis of rotation, which I've marked as an X, and you want to make sure that you know where the force is acting on the object, which again, in case you forget the other video, I'm talking about this point here, where the force kind of originates on the object. All right, now, step two is completely different in this method. Step two says you want to draw a line that is parallel to the force vector and extends infinitely in both directions. And this is called the line of action. So what I mean by that is you want a line to extend backwards like this from the force in that direction, and it could also extend forwards like this. So you're basically visualizing the force vector as being part of an infinitely long line. Okay. The next thing you do is you draw another line which passes through the axis of rotation and is perpendicular to the line of action. Okay, so in other words, we draw another line here. It would be something like this. Okay, so it has to pass through the X and it has to be perpendicular to the other line I drew. These lines might not be exactly perpendicular, but if you want the drawing to be accurate, this should be a right angle where these two lines meet. Okay? Now, what you want to do is measure the distance from the axis to the line of action along the other line you drew. So in other words, what I'm talking about here is you want to measure this distance here from the axis on one end to the line of action on the other end in the direction that you went in the second line, perpendicular to the line of action. And we'll call this R subscript perpendicular because it's the distance perpendicular. And okay, so that is R perpendicular. Now you calculate the torque using a different formula. You take the entire magnitude of the force and you multiply that by R perpendicular. Oh, by the way, R perpendicular is referred to as the lever arm or moment arm. Okay. So now the torque is calculated as the magnitude of the force. So you don't have to break the force into components in this method. You simply take the whole magnitude of the force times R perpendicular. Okay. And then you find the sine of the torque using the same method as the other method, as the force component method. look at which way it would tend to cause the object to rotate about the given axis of rotation. So in other words, the force vector shown here, the axis is here, so it would cause a rotation clockwise in this case. You know, if you exerted a force like this, it causes a rotation in that direction. So that would be negative in this case. And that's about it. So which method is better for calculating the torque? It really depends on the problem. You'll find some methods where the force component method is much clearer and easier. You'll find other problems where the lever arm method is much clearer and easier. For my personal taste, I can always remember and understand why it's the tangential component of the force that causes the rotation and why we're throwing away the other component. In this method, I have a hard time remembering it because I don't really understand why it works that well. How you draw these two lines and things like that, why you're drawing a line perpendicular to the line of action. I mean, it makes sense, but it's a little bit, seems like a magic trick to me. So I'd rather have the method that I can actually wrap my head around personally. But you may not feel the same way, which is also fine. Either of these methods will give you the same answer at the end of the day. So either of these methods is fine and will work.